Hi everyone, welcome back to my channel Structural Diagnostic. In this video we are going to look into the question number 9 from Strength of Materials, and this question was asked in GATE 2011 which was conducted by IIT Madras. The question says a rigid beam is hinged at one end. You can see here it is hinged at one end and supported on linear elastic springs having stiffness value K at point 1 and 2. This is point 1 and this is point 2, and this is supported by these linear elastic spring at 1 and 2, and stiffness value of these two springs is same, that is K. And he says that an inclined load root 2p is acting at point 2 here with an inclination of 45 degree. Now using this information he is asking a question that what are the values of delta 1 and delta 2 at point 1 and 2. So with application of this root 2p with an inclination of 45 degree at point 2, this beam is going to deflect in a particular manner. Due to that deflection, what will be the deflection at point 1 and point 2? So here are the options. Please pause the video and try to solve this. And the solution for this question goes like this. Let the reaction at point 1 be R1 and at point 2 be R2. Reaction at point 1 where we have a spring, here let reaction be R1, and at point 2 reaction be R2. We know that spring constant K is given by P by delta. This beam is a rigid beam. This will not deflect internally, but it will have certain settlement because of these springs present over here when the load is applied. Now first spring 1 deflects by delta 1 and offers reaction R1. When load is applied, as I told, this will have certain settlement here, and spring 1 it will initially deflect by some amount and then it will start offering reaction. Similarly this spring 2, that will also deflect by some value which I consider it as delta 2, and after that it will offer reaction R2. Now what reaction this spring will offer is R1, and that value is going to be equal to K into delta 1. We arrived at this equation using this formula here. Here P is nothing but R1. If you want to have R1 value, I will take this delta next to this K, that is K into delta 1. Similarly R2 will be equal to K into delta 2. The free body diagram and the deformed shape of this beam will be as shown below. That is, this is an inclined load that is going to act on this beam, therefore we will have both the reactions here, that is vertical reaction and horizontal reaction, since this is a hinged support. So this is going to be vertical reaction and this is the horizontal reaction. Now if I resolve this force, that is root 2p, if I resolve this force in its vertical and horizontal component, this is going to be root 2p cos 45, that is going to be again equal to p, because cos 45 is 1 by root 2, root 2 get cancelled, therefore this reaction is going to be equal to p here, this resolved force in horizontal direction is going to be equal to p here, and vertical component of this load is going to be equal to p again, because again sin 45 is 1 root 2, root 2 get cancelled, and therefore this vertical component of this load root 2p is going to be equal to p here. And as I told earlier, reaction at location 1 is going to be R1 equal to K into delta 1, and at location 2 it is going to be equal to R2 is equal to K into delta 2. Now deformed shape, or I can say settlement of this rigid beam takes place in this manner, wherein this is the delta 1 and this is going to be equal to delta 2, and this points 1 and 2 are equally spaced, that is this is L and this is also L here. Now using the concept of similar triangles here, I can write L by delta 1 is equal to 2L by delta 2. Therefore this L get cancelled, and I can say that if I take delta 2 here and delta 1 here, delta 2 will be equal to 2 times of delta 1. Here this delta 2 is going to be equal to 2 times of this delta 1. I'll say this as equation number 1. Taking moment about hinge support we get, so we have a hinge support here, and using all these reactions we are going to take moment about this point in order to calculate delta 1 here. Therefore, we have this vertical force here P. I'll consider clockwise direction as positive and anti-clockwise will be negative. Therefore, P into this is 2L, total L plus L is going to be equal to 2L. Therefore, P into 2L minus this reaction I am considering R1 into L, again minus R2 into 2L, that should be equal to 0 if we consider equilibrium in vertical direction. Now simplifying this, P into 2L I'll keep as it is. R1, we have seen that R1 is equivalent to K into delta 1, so I'll replace R1 as K into delta 1, and R2 is equal to K into delta 2, so I'll replace R2 by K into delta 2, and I have kept all the terms as it is. Now if I take L common from all these three terms, this is the equation I'll remain with, that I'll have, that is 2P minus K into delta 1 minus 2K into delta 2 is equal to 0. Now if I substitute value of delta 2 that we have got here, that is from equation 1, delta 2 is equal to 2 times of delta 1, that I'll substitute here, and all other terms I'll keep as it is. If I simplify it further, 2P minus K into delta 1 minus 2 into 2 is 4K into delta 1, that is equal to 0. Now minus 1K delta 1 minus 4K delta 1 is equal to my 2P minus 5K delta 1, that is equal to 0. When I simplify this, I'll get delta 1 is equal to 2P by 5K. Now from equation 1 we have delta 2 is equal to 2 times of delta 1. Now we have obtained value of delta 1. We'll calculate delta 2 is equal to 2 into delta 1, that is 2P by 5K. Therefore delta 2 value we got it as 4P by 5K. Therefore correct answer for this question is option B, which is delta 1 is equal to 2 by 5 P by K and delta 2 is equal to 4 by 5 P by K. I hope you liked this video. Please like, share and subscribe Structural Diagnostic for more videos on GATE previous year questions related to structural engineering topics. Thank you for watching the video. Have a good day.